So, we've come to the end of the scheme of work, guys. So very well done, everybody. I think you should all be very proud of yourselves. The fact that we've been able to keep up with the scheme of work as if we were in school in maths, I think is a really good effort by you guys. So well done. I mean, I know you're missing out on lots of other things, you know, all your sports and all your extracurricular activities and obviously seeing your friends. But I think it's quite reassuring that from the maths point of view, you know, you haven't lost out. So that's a credit to all of you. So what I thought we'd do as we finish the scheme of work, we'll just treat it as if we were still at school. So what we would be doing now, we would be revising for our end of year exams. Okay. Now, obviously, just to reassure you, I don't want you panicking and thinking we're revising that I'm going to suddenly spring a test on you or something. I'm absolutely not. Okay. So that's not going to happen. Even in the hugely unlikely event that we went back to school before the end of term, there still isn't going to be any testing. But I just think it's good for you guys that you go through the revision process. And obviously, it's important that we consolidate all of the stuff that we've done earlier this year. So my thoughts are that I'm going to cherry pick what I consider to be the most important topics and to really hit those hard and leave other bits and pieces out from the revision process, because as I said, there's no test so we don't need to cover all of it. So I'm really keen that we just get you all very confident with your algebra skills. So a lot of it's going to be algebra, and that also lends itself to the sort of approach we're doing, where I model a bit and then you go and do a Hegarty quiz for the rest of the lesson. So I think some of you have already had a go at these, and I'm fine with that. I appreciate that loads of our lessons are always period 6, which is late in the day. Everybody's getting tired, so I quite understand that some of you are choosing to do the quizzes before the live lesson. Now, obviously, if you are not doing very well in those quizzes, then don't worry about it. Just wait for when I model it and do it later. But clearly, if you're able to get 100% or something, clearly, if you're able to get 100% or something, then that's great. So I'm not going to criticize any of you for doing the work early, but just have a care. If it's not going very well, don't panic. Just wait for the live lesson. So solving linear equations. I just want to model some of these just to remind you how we do these. Okay, so I've handwritten them, but these are 3 of the questions, the standard of the Hegarty maths. Right, I'm just struggling to get the pen working at the second. There we go. Okay, so our goal is to get all the x's to one side and all the normal numbers to the other side. And your strategy should be to get all your x's over to the side with the biggest number of x's. So on this occasion, 5x is obviously bigger than 3x. So we want to get all our x's over onto the left-hand side. So we need to undo this 3x here. So we're going to choose to take away 3x from both sides. And if you remember, whatever we do to one side, we've got to do to the other side to keep things equal. So I would suggest you go and write your minus 3x in a circle under both the x's, just doubling it up on both sides just to keep things equal. So we now process that instruction. So what is 5x take away 3x? Well, that is 2x. Well, our normal numbers aren't impacted by an instruction which just affects the x's. So that minus 9 is just brought down. Over on the right-hand side, 3x take away 3x is nothing. That's the whole point. That's why we chose to take away 3x. And that plus 3 is unchanged. So we've now achieved our first goal, which was getting all our x's over onto the left-hand side. On this occasion, we want to go and get all our normal numbers onto the right-hand side. So the 2x is fine. The plus 3 is fine. They're on the correct sides. It's this minus 9 that needs to go. So how do we undo a minus 9? We add 9 to both sides, of course, and we process that instruction. So 2x is what we're left with. So 2x, 9 minus 9 add 9 is nothing, and 9 add 3 is 12. So 2x equals 12. Halve both sides, so divide both sides by 2, and we of course get x equaling 6. Now, you might better rattle through these 4 questions or whatever quite quickly. It's ever so important that you're getting into good habits with regard to your workings. So please, can you set your workings out exactly as you can see on the board at the moment? It would be great if you got the chance to upload your workings for me to have a look at. Not many of you are choosing to do that at the moment. That's fine, you know, as long as you're getting good percentages, that's what really counts. But I would love the opportunity to see your workings. So if you can upload those to me on Teams, that would be great. So let's model the second one. Now, on this occasion, our greater number of x's are on the right. So I want to move all our x's to the right. So it's the 2x that's got to be undone. So we're going to choose to take away 2x from both sides. So there's the instruction in a circle. Process that instruction. 2x take away 2x is nothing. The +4 normal numbers aren't affected by an instruction that's just impacting the x's. 6x take away 2x is 4x, and of course our -9 is unchanged. So on this occasion, all our x's are going to the right, so all our normal numbers have to go to the left, so it's the -9 that has to be undone. How do you undo a -9? You add 9 to both sides. So 9, 10, 11, 12, 13. Excuse me. And 4x on the right hand side, because the 4x is unchanged. -9 add 9 is nothing. Now, on how do we undo this 4? 4x means 4 times x times 4. We're going to choose to divide both sides by 4. That's how we undo that timesing by 4. Now, on this occasion, 13 divided by 4 does not give us a whole number. Okay, now I don't know off the top of my head whether Hegarty wants you to give a top-heavy fraction like 13 over 4, or whether you've got to go and get your calculator and work out that that is 3.25. You'll just have to check. You get a couple of goes, don't you? I suspect you've got to put in the 3.25. If it was me in a normal lesson at school, I would prefer you to leave that top-heavy fraction of 13 over 4, but you just have to check. I can't remember. I don't know. Okay, but do be careful. It's 13 being divided by 4. That is 13 over 4, not 4 over 13. Right, final example. Okay, so on this occasion, the biggest number of x's is on the left. So that's where all the x's are going to go to. So these are the x's that have to move. So we take away 2x from both sides, giving us 4x plus 2 equals -1. Careful, it's the -1 you're bringing down. So x is on the left, normal numbers are going to be on the right. So it's the +2 that's got to go. How do we undo a +2? We take away 2 from both sides. Okay, so we're left with 4x equals, be careful, think your number line, -1 take away 2 is -3. And then how do we undo this timesing by 4? We divide by 4. So our final answer is x equals -3 to be divided by 4. And as I said before, I suspect they want it to be a decimal answer. So I expect it's -0.75. So really important topic, guys. So go and give this your best shot, please. You know, it's really important. It would be great if you could keep going until you go orange, until you get a 70%. Obviously, I don't want you overrunning your normal lesson time. So, you know, stop when your time's up. But if you don't get to 70%, put this on your to-do list. So another time when you're doing maths and you've finished quickly, come back and try and improve the mark on this one. Okay, guys, that's it. Okay, good luck with that. As always, I'll be here, keeping an eye out on Teams, and obviously feeding back comments as you complete the Hegarty exercise. Cheers, guys.